Robot Talk is the podcast that sits down with robot enthusiasts from around the world and asks them the questions you always wanted answered. Like, how do you sell a robot? And how does that thing work? Hello everyone, welcome to Robot Talk. I'm your host, Claire Asher, and this week's episode is about the challenges of commercialising robotics innovations in the UK and how the government can support businesses to make use of the latest robotic technologies. But first, I'd like to invite you to join the Robot Talk community on Patreon, where I'll be sharing behind-the-scenes updates and you can chat with me and other Robot Talk listeners. You can also sign up to support the podcast for just £5 a month. And if you do, not only will you get a warm, fuzzy feeling for helping me to keep producing and expanding the podcast, but you'll also get access to exclusive bonus episodes and lots of other cool perks. Check out patreon.com/Claire Asher to find out more. The first 20 Patreon supporters get a free sticker, so don't procrastinate, join today. So, with all that said, let's get on with this week's interview. I recently had a great chat with Jonathan Walker from Innovate UK about translating robotics research into the commercial sector. Today, I'm chatting to Jonathan Walker, Innovation Lead for Robotics and Sensors at Innovate UK, working to accelerate the development and uptake of robotics in the UK. Hi Jonathan, lovely to have you on Robot Talk.
Hi Claire, thanks for having me on the podcast.
So for listeners who aren't familiar, can you start out by telling us a little bit about what Innovate UK does?
Sure, of course. Innovate UK is the UK's innovation agency. So our mission is to help companies grow and develop and commercialise new products, processes and services. We do this in an agile, inclusive and easy to navigate way, hopefully. In practical terms, that means we get money from Treasury through DCIT or other government agencies and then distribute this as grants, either themed competitions or open ones like the Smart Grants.
Okay.
Other mechanisms as well, such as contracts for innovation or investor partnerships where we bring in private investment as well. And there's also lots of non-financial help. So through our partners Business Connect, who help to bring people together, advise on support, run events to showcase tech and ideas. Business Connect also has something called Analysis for Innovators.
Okay.
So that is where a company can come with an existing problem in a process, and we link them up with partners that are able to help with that, and we fund the projects as well. So they're usually quite small projects, maybe up to £20,000. Pounds, and it can be anything from a process where you've got more variation than you would like, and we can have partners come in and look at the process and see why there's more variation and perhaps fix it. There was one example where a company were throwing away 20% of their production, and the partner came in, looked at the process, did a fairly simple fix, and then 100% of the production was then suddenly available.
Brilliant, yeah.
So yeah, it's a fantastic way to increase the efficiency of your processes. And we also have another mechanism called Innovation Exchange Challenges, where companies can come to Business Connect with a challenge, and we post it on our website without presupposing the solution. So it's a good way to invite solutions from sectors or companies that you may not have otherwise thought of.
Yeah.
And it's also good for the solution providers. They can apply through a really light touch application process, just 3 questions. And if they're successful, they go to a pitch day with the company. And it's a Crown procurement approved procurement process. So they can then go straight into a business transaction and procure that service. So yeah, it is a fantastic way of getting your technology into a large company.
Yeah.
And they also have their own programs as well. You may have heard of knowledge transfer partnerships, or KTPs. That's a long-running program that's been going for 50 years. It's a collaboration between a university and a business. The knowledge transfer associate works on a 2-year project, and it's 2/3 funded by government.
Okay.
So a really good way to get a project done that your business wouldn't normally have time for. And it's a two-way exchange of information. So the business is getting expertise from the university, but the university is also learning from the businesses.
Yeah, and I mean, this is so important because I think so many of the guests I've spoken to have talked about this kind of, I think they call it the valley of death, of just like the difficulty of getting research out of universities and into the commercial sector is just huge.
Absolutely. Some of the reasons for that are university research is, of course, cutting edge, but subject to funding cycles. Also, people working on a PhD, once they've finished the PhD, filed their thesis, they may not want to carry on with that line of research, and sometimes it just gets shelved. Ways that we can overcome that are many. Government funding is one of them. We tend to fund the research up until kind of technology readiness level 6. And then there's a bit of a gap before private investors or companies are able to commercialize. Certainly for robotics, commercialization is a really long process. It can be 5 to 10 years to go from prototype to something that you can have in the market being sold. So there is definitely a gap there, and it's something that we need to really help companies over.
Yeah. So I have heard this phrase a lot, technology readiness level, but I don't know what the scale is, or like, is it 1 to 10? How does it work?
It is 1 to 9.
Okay.
It was something that was originally thought up by NASA, I believe, or US Air Force. And 1 to 2 is really foundational research. And then once you get into the 3 to 6, that's a prototype and beginning to do testing. And then 7 to 9 is getting that product ready for market, mass producing it.
Fantastic. It's good to finally get the answer to that question.
Well, I may not be completely correct on that. It's not one of my subjects of speciality, but...
Fair enough. So I think we might have already covered this a little bit, but at the moment, what are the biggest obstacles to new robotics innovations making their way into the real world, as it were?
Well, as you say, we already talked about the difficulty of research jumping from university to commercial world. Other issues for startups are funding their prototype. We can give them some money from government to develop the prototype, but usually it'll only be, I don't want to use the TRL scale again, but it'll only be to a kind of a basic prototype. So it's able to do the task, but it's not ready to be mass produced, and it may not comply with regulations, for example. So as we said, commercialization is a long process. We can try and help companies to secure private investment, and we do have some private investors that we collaborate with that are willing to take on a bit more risk. Okay. That's where the investor partnerships come in, because Innovate UK will pay 1/3 of the investment. So that's a nice way for private investors to manage the risk a little bit.
Yeah.
And regulation can also be a barrier. A lot of regulations were developed before the development of autonomous systems. So they need to be adapted for modern technology.
Yeah.
Couple of examples. In the marine environment, it's regulated by the MCA, the Maritime and Coast Guard Agency. So they have a regulation called the Workboat Code, which regulates against all marine vehicles that are under 21 meters long, which is quite large. And the same regulations apply to a micro vessel that's 1 meter long and a really large thing that goes very fast. And the difference in risk between these two vessels is huge. And there are things that apply to a large vessel that wouldn't apply so much to a small vessel or even an autonomous vessel, because there are regulations about having life jackets on board, for example. And that doesn't apply if you don't have people on the vessel. So the MSA have recently released on the 5th of August a new part of the regulation to regulate specifically for vessels under 5 meters. So that's a really positive step forward. And companies developing these uncrewed surface vehicles are working with the regulator to try and craft the regulations to help innovation. There is also a national RAS, which is Robotics and Autonomous Systems Regulations Committee. That's chaired by Professor Samia Nefti-Meziani of Birmingham University. And that's fantastic. It's bringing together regulators from UK rail, space, marine, construction, nuclear, all different sectors to talk about regulations and how they can be adapted for robotics and autonomous systems. And one of the really interesting things that came out of it is that we don't actually need new regulations. It's new working practices that are necessary. So taking those regulations and applying them to new situations where you're using autonomous robots in the real world. So really exciting.
Yeah, that's brilliant. It's good to hear that policies and regulation is kind of starting to catch up.
Yes, absolutely. Other challenges are the UK is a really small market. Certainly for robotics, there's not a big demand for robots. So unless companies are able to secure public procurement through one of our mechanisms called contracts for innovation, so that would be a contract with a government agency like the NHS or DEFRA. Unless they can do that, then it's a very small market and they really need to try and export perhaps before they're ready. And then that's a very expensive process. Certainly if you're exporting to the US, you need to have a base in the US and employ people there. So very difficult for a startup to do.
Yeah, absolutely. So we have an audience question that was sent in by Martin on the website. So Martin says, how can we assist each other to promote and develop robotics in the UK? And I think this is coming from an industry perspective.
Really good question. Thanks for that question, Martin. I think it's important to take the opportunity to speak about the positive potential of robotics whenever we can. So I'm very keen to attend conferences or talk about robotics in work meetings, even when people may not be so interested sometimes. Even when you're down the pub with your friends, just bring up robots and talk about them. The public perception of robots can be that they're dangerous, bad, they're going to take away our jobs, or they're very expensive. But robots often pay for themselves in a 2 to 3 years return on investment. And it's been proven in several studies that when companies bring robots in, it actually creates more jobs because they're able to produce better, more efficient products or services, and that allows them to grow the business. We can also share ideas between sectors, so don't need to start from scratch in agriculture. For example, you can bring innovations in from manufacturing, or a lot of the things that are being developed in agricultural robotics would equally apply to construction, for example. Similar environments, dirty, muddy, messy, and really jobs that robots can be used to take away the dangerous parts of the tasks. Not the jobs themselves, but the dangerous tasks.
Yeah, absolutely. So one area you're particularly interested in is technologies that can help us transition to a circular economy. And my kind of ears pricked up when I heard this because I'm really interested in the circular economy. So for listeners who haven't heard about the idea before, circular economy is about minimizing or eliminating waste by keeping materials in use. So can you talk a bit about some of the ways that robotics can help us with this transition?
Absolutely. It is an area that I'm very keen on as well. It's important to leave a legacy for our children that is not going to harm them.
Absolutely.
So robots can help with remanufacture of products. So engines, for example, it takes a lot of resources and time and money to produce an engine. When it gets to the end of its life, you could use a robot to remanufacture it, rebore the cylinders, for example.
Okay.
They can also be used to sort materials in a recycling plant, so separating out the paper, metal, plastic, different types of plastic. It's amazing how many different types of plastic there are.
Thousands.
And really difficult to tell the difference between them sometimes just by using a camera. They can also be used to dismantle components. So imagine recycling televisions, for example. It's quite a difficult, dangerous task for a person. There's lots of sharp edges, potentially chemicals inside there. So you don't really want people being close, hands-on with recycling of televisions.
Yeah.
But using a robot, you can do it in a more safe way. It's a difficult task. There's lots of different brands, models, types of television, different sizes. But another benefit of that is that we can recover some of the critical materials that are inside there, particularly from things like car batteries, where there's lots of lithium, which I think there are some lithium mines in Cornwall, but it's not a material that's generally found in the UK, and it's often mined in China or Africa, and conditions where it's mined are not good for the people that are mining, socially or financially. So if we can retain those critical materials within the UK, then it's great for the circular economy.
Yeah.
Other materials are the rare earth that you use in magnets. From the motors on an electric vehicle, or going to large scale, the wind turbines. So the generators inside them have got huge magnets, and you can imagine it's a very difficult and dangerous task to remove them in a safe way.
Yeah.
So there's some work being done around getting the magnets out and recycling them.
Yeah, brilliant. So I know you mentioned other areas of interest for you are construction and infrastructure. So do you want to talk a little bit about how robotics is getting involved in that?
Sure, certainly. I tend to think of the challenges when looking at areas where robots can be applied.
Yeah.
So in construction, the government has set a target of 370,000 houses built per year, which, it's going to be very difficult to achieve, especially considering the average age of the workforce is 55.
Oh, wow.
In the construction industry. So if we can use robotics to build modules off-site and then transport to site to be connected together, then firstly, it takes away some of the dull, dirty, dangerous tasks, makes it more efficient and cost-effective, but it could also attract younger people into the industry.
Yeah.
So I think that is a really good way. On the infrastructure side of things, the MTC, the Manufacturing Technology Centre, Catapult, has estimated that there's going to be 200 billion of infrastructure repairs needed by 2050.
Wow.
So to try and mitigate that and reduce that number, we could use robots to survey some of the infrastructure, railway tunnels, bridges, for example, identify the ones that really do need maintenance, and then target maintenance where it's needed most.
Yeah, I've heard as well about 3D printing drones that can kind of fly in and repair roads and stuff like that.
Exactly, and even environments that we really don't want to go in, like the underwater pipe work. So water pipes, sewage pipes. It's a great application of robots.
Yeah, definitely. So you speak to people working in all different areas of robotics, in industry, in academia, in the government. What area of robotics do you think there is the most excitement about currently?
Well, currently it seems that humanoids are the most exciting part.
Yeah.
There's been some amazing advances in the last few years. We keep seeing different videos online, and I've even met a couple of them at events. So yeah, it's really exciting to see. And being a science fiction fan, I really like to see these humanoid robots. However, I think they still have a long way to go.
Yeah.
I saw a video online recently of a robot picking up a rucksack and handing it to someone, which, it seems quite an unnecessary task and quite a simple one. Perhaps if it was able to hang the washing on the line or fold your clothes for you, then it would be much more useful.
Yeah.
Control is a major barrier. So interaction with people are random. We do chaotic things. It's very difficult for robots to predict. And dexterity is another issue for robots. There's some amazing robotic manipulators like the shadow hand. But this is very expensive. It costs about the same as one of the humanoid robots. So not really a practical solution. But robots must be useful. Otherwise, they're just toys, really.
Yeah. I have mixed feelings about humanoid robots because I understand the kind of, there's this draw of being able to mimic everything that a human can do. But at the same time, I feel like sometimes it's separate from like the actual functionality. It's just like, oh, it'd be really cool to make a humanoid robot and we'll figure out what it's going to do later, versus like making robots that are actually going to be useful.
Yes, I completely agree. And I think in a factory setting where you can adapt the environment to the robot, then it's less necessary to have legs, for example. You may need that by manipulation of having two arms work together, but certainly having a anthropomorphic head on it doesn't really make any sense in a factory environment. In the home, it's much more difficult to adapt every home to robots. So there could be a case for humanoid robots being able to fit into the home environment. Everything's designed around the kind of human form, even down to the height of cupboards and things like that. So, I mean, there is a case for that there. However, the UK has never been in the race for developing humanoid robots. We're probably a decade behind places like China and USA. So I think for us, we need to focus more on things that we are good at. So being an island, we have quite a few companies that work on marine autonomy, as I mentioned earlier. That could be a real growth area, especially in the context of building all these offshore wind farms that are being planned. Another one is nuclear decommissioning. So we've spent 60 million, I think, on robotics for nuclear decommissioning through the ISCF between 2019 and 2022. And it'd be nice to see some of those things being commercialized and exported to other countries. We did a collaboration with Japan called Long Ops around robotic inspection of Fukushima. So, of course, there's a lot of really difficult, dangerous work to do in Fukushima to make it safe and get all the nuclear materials out of there. So I think robotics really has a place there. And also in horticulture, we've got quite a few companies developing robotic products for horticulture. So picking raspberries, picking apples, strawberries. And these are areas where we can't get the labor to do these jobs. So it's a nice niche for robots as well. Other challenges that we need to focus on are the aging population. So we're all getting older. Not as many people are having children at a young age as they used to. We've got an aging population. Japan is ahead of us in this respect. Their demographics are aging faster.
Yeah.
But I don't know the exact statistics, but there will come a time when there's more people who are not working than there are working.
Yeah.
So really need robots to help us with carrying out all the jobs that are not being done.
Yeah.
I mean, one way to look at it would be to have robots looking after our elderly, but I'm not sure I like that really. It could be quite disorientating for someone, especially if they've got some dementia or Alzheimer's, for example. It'd be much nicer for the robots to do the jobs and then leave people more time to look after their elderly relatives.
Yeah, absolutely.
There's a couple of schemes in China and Japan where you get social credits for looking after elderly. And then I think if you build up enough, then that guarantees your own care when you're elderly.
Okay. Oh, that's clever. I like that. Yeah.
It's nice, but it's going to take some political intervention to be able to do that, of course.
Yes. But yeah, I hear what you're saying about get the robots to do the jobs that robots are good at, and people are uniquely good at looking after other people. So let's stick to what we're good at as well.
Exactly. And same thing could apply in the NHS. So there's a shortage of nurses, but robots are never going to be able to do the patient-facing job of a nurse. But they could help with the other tasks that the nurses do. So cleaning, moving medicine around the hospital, and freeing up the nurses to spend more time with their patients.
Yeah, absolutely. Jonathan, it's been fun speaking to you today. I've been talking to Jonathan Walker from Innovate UK. Thank you.
Thank you.
Thanks for listening. If you enjoy Robot Talk, please share the podcast, subscribe, and leave a review. And if you've got a question you'd like me to ask one of my future guests, you can contact me on social media at Robot Talk Pod, on Patreon at patreon.com/Claire Asher, or at robottalk.org. I regularly announce upcoming guests on all those platforms, and I'd love to include your questions in my next interview. Next week, I'm talking to Maria Elena Giannaccini from the University of Aberdeen about soft robots in medicine and healthcare. Until then, I've been Claire Asher, and this has been Robot Talk. Robot Talk is brought to you by the Hamlin Centre, Imperial College London.